In other videos, we talk about how a current flowing through a wire can induce a magnetic field. And we're going to talk about in this video is how we can go the other way, how a change in a magnetic field can affect or induce a current in a loop of wire. So we're going to be going from a change in, and actually we're going to focus on magnetic flux, magnetic flux through a loop. Through a loop, and we're going to see how this actually induces a current in that loop. So it induces a current, induced current. So this right over here, this is my attempt at drawing a magnetic field. These are the magnetic field lines. They don't look like lines because they're all popping out of the screen. They're moving towards you, towards the viewer. So you can view these as the tips of the arrow. And there's different ways of showing magnetic fields. You could show magnetic field lines like this. You could also use vectors. And when you're using field lines, it's the density of the field lines tell you how strong the magnetic field is. So if you go to the right here, they're less dense, so the magnetic field is less strong on the right-hand side over here than they are on the left-hand side, or at least that's what I'm trying to depict. Now, if we did it with vectors, we would have bigger arrows pointing out over here than we would over there. But now let's do a loop of wire. Let me draw a loop of wire here. So let's say I have a loop of wire that is, so this is my loop of wire. So if I just throw that loop of wire, and if it's just stationary and it's in this magnetic field and the magnetic field isn't changing, I do have some flux going through the, I guess you could say, the surface defined by this wire. And if you're unfamiliar with the term magnetic flux, I encourage you to watch the video on magnetic flux. But if I just have this wire stationary in the magnetic field, nothing is going to happen. But I will be able to induce a current if I change the magnetic flux going through this surface in some way. So for example, right now the magnetic field is pointing out of the screen. If I were to make it even stronger in the direction pointing out of the screen, so I guess one way to think about it is if the change in the magnetic field, the change in the flux were to get even stronger in the outward direction. So I don't know a good way to, so it's going to get even stronger in the outward direction. I'll draw a big arrow there. I guess you could say that these things became even denser in this outward direction. It is actually going to induce a current. And the current that it will induce is going to go in that direction. And let me draw it a little bit clearer. The current is going to go in that direction. It's going to go in a clockwise direction around this. And that is because that change in the magnetic flux that induces a voltage, an electromotive force that causes this current to flow. And there's other ways to change the magnetic flux. If I were to lessen the magnetic field in the outward direction, or another way, if the change in the magnetic field were inwards, then the current would go the other direction. But the key here is when I change the flux through this surface defined by this wire, it's going to induce a current. The current isn't going to be there if the magnetic field is stationary and I'm not changing this loop in any way. But as soon as I change the flux in some way, I am going to induce a current. I could also, instead of changing the field, I could actually move my coil. I could move it that way. And if I were to move it that way, the flux going through this surface, or I guess coming out of this surface, will increase. Because if I move this to the left, the magnetic field is denser, I guess it's stronger, so there'll be more flux through this area here. So if you move it that way, you also would have a current like this. Now if you moved it the other way, if it was on the left-hand side and you moved it that way, it would also induce a current. But now since the flux is lessening in the outward direction, the current would go in the other way. Now there's other ways to change the flux. You could actually change the area of this actual loop. If somehow it was made out of some maybe stretchy wire somehow, if you increased, let me draw it this way. If you were somehow able to stretch it so it contains, so the actual area increases. If you're able to stretch it out so that the actual area increases, which would cause the flux in the out of the screen direction to increase even more, that also would induce that also would induce a current. And so this whole idea of a change in magnetic flux inducing a current, this is the essence, and we'll go deeper into it in future videos, this is the essence of Faraday's law. Faraday's law. And we'll quantify this more in future videos, but it's just the notion that if I have a loop of wire and I have a changing magnetic flux through the loop of wire, that is going to induce a current in that wire.